right, this is section 6.3. We're going to use trigonometry to solve for a missing side. We're going to be given an acute angle and at least one side, and we're going to be asked to find another side, the length of another side. So I want you to read through these steps that we're going to go through. And then we're going to dive into the examples. So we're going to write an equation. Here's our instructions. Write an equation using a trig function, and then we're going to use that equation to solve for x. We're going to find the measure of the indicated side, and that side is going to be marked as an x. So look at a picture down here. We're looking for the length of side AC. So the length of x, the value of x. So what's our first step? All right, our angle that we're looking at is 54.7. And in relation to that angle, the x is the opposite. So I'm going to label that as opposite. It's the opposite leg. And then the 7. What's the 7? Think about what the 7 is. The 7 is across from the right angle, so it's the hypotenuse. Now, I really don't have to label the other leg. This will be enough. If you want to label the other leg, you can, but these are the two I'm going to work with, the opposite and the hypotenuse. So that will help me figure out which trig function I need to use. If I'm working with the opposite and the hypotenuse, remember SOHCAHTOA. Let me write this up here on how to help us choose. SOHCAHTOA. Right? However you were given that mnemonic for memorizing the trig function. Sine equals opposite over hypotenuse. So if I'm working with the opposite and the hypotenuse like I am in example 1, I'm going to need the sine function. That's how we choose. Sine is opposite over hypotenuse. So I'm going to write down my equation. So I'm going to use the sine function. That's the one I want to work with. So I'm going to write down my equation. Sine of the angle, which is 54.7, needs to be the opposite leg divided by the hypotenuse. Now I have an equation that I can solve for x. And it's going to be an easy equation to solve because to undo dividing by 7, notice we've got x divided by 7. To get the x alone, I need to multiply by 7. So I'm going to multiply both sides of that equation by 7. So I will have 7 sine of 54.7 degrees is equal to x. And then I'm going to grab my calculator, and I'm going to round it to the nearest tenth. So I'm going to use an approximation symbol since I'm rounding. I'm going to grab my calculator, and I want to make sure it's in degree mode. So check to make sure it's in degree mode. If it's not, because remember, every time we clear the calculator's memory, if it's not in degree mode, you arrow down and across. You highlight the word degree and you push enter, and it will be in degree mode. Mine was already there, but that's how you do it if it's in radian mode. So I'm going to leave there, and I'm going to do 7 times the sine of 54.7 degrees, and I get 5.7. Rounded to the nearest tenth, that is 5.7. So my answer, x is 5.7. Remember, the squiggles means we've approximated, we've rounded it off. Okay, example 2. I have a 90-degree angle in the corner here. 60-degree angle is up here. But notice the x is the hypotenuse because it's opposite the right angle. And opposite the 60 would be over here. So I don't have the opposite leg. I have the adjacent leg. Okay? And I'm just going to use those two labels. Those are the two I'm working with. So if I just label the two that I'm going to work with, it might make it easier to figure out which trig function I need. Adjacent and hypotenuse, which one uses that? That would be cosine. Cosine is adjacent over hypotenuse. So we're going to use the cosine function. So let's write down our equation. Cosine of the angle is 60 degrees. Cosine of 60 degrees is adjacent, which is 5, divided by x, which is the hypotenuse, where cosine is adjacent over hypotenuse. That's where that's coming from. So now I need to solve for x. So I've got to get the x out of the denominator. Look, it's in the denominator. I've got to move it out of the denominator. So what I'm going to do is I'm going to multiply both sides by x. That will undo the divide by x on the right-hand side. And then to solve for x, I need to divide both sides by cosine. So I have x equals 5 divided by the cosine of 60 degrees. Let's think about that. If I have x cosine of 60 equals 5, I can divide both sides by cosine to undo this multiplication. But whatever I do on one side, I have to do the same on the other. So that's what's happening, is we're just dividing to get the x alone. Okay? And we're going to grab our calculator, and we're going to come up with a decimal approximation for this. So let's go to our calculator. We're going to do 5 divided by the cosine of 60 degrees. Push enter. Oh, it's exactly 10. Yes, this is a special right triangle. It is exactly 10. So I don't need the approximation symbols. It is exactly 10. So I'm going to do equals 10. X equals 10. And we're done. Okay, for example 3 and 4, I need to explain something about how we label triangles. So if I have a right triangle, if this is angle A and this is angle B, we are going to consistently put angle C as the right angle. So when we do these problems, when we have a triangle ABC, a right triangle ABC, and we're going to assume that we have right triangles in every problem. If we have a right triangle, the 90-degree angle is at vertex C. All right? That would mean the hypotenuse is across from it. We're going to use the label little c for that. So little c is opposite angle C. Little a is going to be opposite angle A. Little b is going to be opposite angle B. So look at the setup. Little a is opposite angle A. Little b is opposite angle B. And the hypotenuse is opposite the 90-degree angle, which is always going to be vertex C. That's the setup that we need to remember. So we're going to, in example 3 and 4, our first step is going to be to draw a triangle. So when I do example 3, I'm going to draw a right triangle. I'm going to draw this one this way. They don't have to be drawn to scale. I'm going to put angle A here, angle B here. Angle C has to be the right angle. So the hypotenuse is 4. It's across the triangle from the right angle. Angle B is 44 degrees. So I have a 44 degrees in that corner at angle B. And then I need to find little b. And that's going to be opposite angle B. So across the triangle. Okay. And while I'm at it, I'm going to label these. The 4 is the hypotenuse. I'm looking for the opposite leg, the leg that's opposite the 44-degree angle. And get a better label on that. This is my opposite. So I've got the labels done. Now I'm looking for B, right? I want to find the length of B. So we're going to write down our trig function that we're going to use. We're going to use the sine, because sine uses opposite and hypotenuse. So let's write down our equation. Sine of 44 degrees. Trig functions operate on angles, so the angle needs to be inside the trig function. So we do the sine of 44 degrees. That's not multiplication, it's sine of 44 degrees. That equals the opposite leg over the hypotenuse. Because remember, sine is opposite over hypotenuse. Okay. Now we need to solve that for b. Well, that's going to be easy because to solve for b, I just need to multiply both sides by 4 to undo the dividing by 4. So sine of 44 degrees times 4 is going to equal b. We're going to grab our calculator, and we're going to do 4 times the sine of 44 degrees, and we have 2.8. 2.8. All right. Let me double check that. 2.8. Sure enough, 2.8. Okay, so let's go back. We have b is approximately 2.8. All right. Last example. Example 4. We're going to find b if a equals 4 and the measure of angle b is 22 degrees. So let's say I drew my triangle, or that my triangle was drawn a little differently. Maybe my triangle is drawn like this. And I have a right angle in the corner here. Maybe this is A, this is B. The right angle is over here at C. Let me start over here. So the first thing you're going to do is you're going to draw your triangle. That's the first thing. All right. So I have A, B, and I have a right angle over here at C. Angle C has to be the right angle. So I have 22 degrees over here in this corner for B. All right. I'm looking for the length of side B, which is across the triangle from angle B. All right. So that's going to be my opposite leg. It's opposite the 22-degree angle. Let me make that look more like a... Make sure you can read your writing there. Right? Oh, that didn't work out so well, did it? I'm going to have to start fresh. So we've got a 22-degree angle here in the corner. 22 degrees, right? 22 degrees. Make sure you can read that. 22 degrees. And the A is across the triangle from angle A. So little a is across the triangle from angle A. And that would be the, in relation to angle B. Be careful. We're not going to label this as an opposite. I already have an opposite. So we're basing our labels on this angle right here, this 22 degrees. B is opposite, and the A is the adjacent leg. The hypotenuse would be down here. I don't need the hypotenuse. Okay? So I'm not going to, you don't even have to label that one if you don't want to. I don't need that one. I'm going to work with the adjacent and the opposite. Okay? So which trig function works with the adjacent and the opposite? That would be tangent. TOA. Tangent is opposite over adjacent. Okay? So we're going to do tangent of 22 degrees equals the leg opposite, which is B, divided by the leg adjacent, which is 4. And then we're going to solve that equation. So to solve that equation is going to be pretty simple. We just need to multiply both sides by 4, and we'll be finished. Other than grabbing the calculator and finding out what that is. So we have 4 times the tangent of 22 degrees. That's going to equal B. Four times the tangent of 22. So we grab our calculator. We do 4 times the tangent of 40. Well, it wasn't 44, it was 22. Got somewhere I didn't want to be. So we'll start over. 4 times the tangent of 22 degrees. And that is going to be 1.6. So B is approximately 1.6, and we are finished.